using isosceles and equilateral triangles. Recall that we've learned an isosceles triangle has two sides that are congruent. Those two congruent sides have a name there called the legs, and the angle where the vertex intersect, in this case, is angle 1 in our picture. That's called the vertex angle. Now, the side that's opposite the vertex angle, this right here, that's called the base. And these two angles, angle 2 and 3, those are called the base angles. So the isosceles triangle theorem tells us if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So if AB is congruent to BC, then angle A is congruent to angle C. Okay? And the converse is also true. So if the two base angles are congruent, then the sides are congruent. So if angle A is congruent to angle C, then AB is congruent to BC. Okay, so next we have the corollary to the base angle theorem, and that says if a triangle is equilateral, that means all sides are the same, then it is also equiangular. Three congruent sides, angles, is three congruent sides. Okay, and we've seen that. So we remember we've got our equilateral triangle. So then we also know all three angles are the same. And the corollary to the converse of the base angle theorem says that if a triangle is equiangular, then it's also equilateral. Okay, so basically in the math terms, if we know that all three sides are equal, then all three angles are equal, and we are going to know that they are all 60 degrees because the sum always has to be 180 degrees. So if they're all the same, they must be 60 degrees. So a triangle is equilateral if and only if it is equiangular. So here we say angle A is equals angle B equals the measure of angle C. Then we know that sides are equal. And if we know the sides are equal, then we know the angles are equal. Okay? So let's see an example here. We have an isosceles triangle. It's given here and here. So in this example, if we know the base is 68, then we know measure of angle J is also 68. The two base angles are going to be congruent. And then we can figure out the measure of angle K because 2 times 68 plus the measure of angle K equals 180. So that's 136 plus the measure of angle K equals 180. We can subtract. So the measure of angle K equals 44 degrees. That doesn't look like a K there. Measure of angle K. So, all right, so that was an example of our base angles. Here we're going to just name two congruent angles. So we said angle or triangle DEF, and then we know DE is congruent to DF. So the two congruent angles we name just angle F is congruent to angle E because those are our two base angles. Now here we have a equilateral triangle. All sides are equal. So if we know that, then we know that these also have to be equal. And I already mentioned this a little bit, but let's prove this. So we know 3x equals 180 because every triangle adds up to 180. So you have x equals 60 degrees. Every triangle, all three angles is 60 degrees. No matter what the length of the sides, the angles are always 60 degrees if it's an equilateral triangle. So here we have a diagram that has an isosceles and an equilateral triangle. Here's my isosceles triangle, or sorry, here's my equilateral triangle rather, and here's the, oops, that's not what I meant to do. Here's the isosceles triangle. It is not wanting to do this. Okay, here's the isosceles triangle. Right there. Okay, how do I know that's isosceles? Well, if you notice, these two base angles are marked as congruent. So because the base angles are congruent, we know that the sides are going to be congruent. So first of all, we can say they've given us the side here for this one equilateral triangle. So we know all of these sides are going to be 7. So we know x equals 7 because all sides of equilateral triangle are equal. And then we can solve for y with the isosceles triangle because we know those two sides are going to be congruent. So we could say 7 equals y plus 4. So y equals 3. And that's how we solve that. Lastly, let's see one more example. They tell us this is an equilateral triangle, so we are going to set all sides equal to 0 or to each other. So let's see. First of all, let's solve for x. We know 7x minus 3 is the one angle, and every angle is 60 degrees in equilateral triangles. So we can set that equal to 60. So we get x equals 9. Okay, and then now we're going to solve for y because we know that all the sides are equal as well. So we can really just set any two of those sides equal to each other. So we can say 11y minus 23 equals 9y plus 1. And if you do that, 2y equals 24, y equals 12. You could just have easily used any of the other sides. So you could have said 14y minus 59 equals 9y plus 1. It doesn't matter. You could have used either. So now it's your turn to go and give the extra practice a shot before you start the homework.